So what are forms? Windows Forms, affectionately known as WinForms, is a subset of the .NET framework. It's used to create graphical user interface or GUI applications. A form with a lowercase f is a special type of Windows control that's designed to contain other controls, and it forms the basis for this entire ability to make graphical user interfaces. Let's sort of get some terminology straight and define exactly what a form is. Here's a form, a blank one, but a form nonetheless. This one has a control box and a title in the title bar of the window. The minimize, maximize, and close buttons are to the right, while the border acts as the edge for the entire form or window. The container area, sometimes called the client area, is where the form's controls and content will appear. Note that this particular form is from Windows Vista, but the forms you create will take on the appearance and theme of whatever operating system they're running on. Controls are the graphical user interface elements that live inside or on a form. Things like buttons, drop-down boxes, text boxes, labels, checkboxes, radio buttons, pretty much almost anything, and they exist on a form. They're contained within it. So if you think of what a dialog box might look like, then you're thinking in the right direction. Let's take a look. Here's a form with some controls on it. You're looking at a label, which is a descriptive text section, a text box, where the user can type something, and a button, which the user can click. All of these appear within the container area of the form. Just like everything else in Windows PowerShell, controls are objects. They have properties like text, value, width, height, top, left. Width, height, top, and left are important because they control the control's position. Many of these controls have got methods too, like click or hide or show dialog and so forth. And some of them have events. It's like change, which tells you when the contents of a text box have changed, or click, which tells you when a button has been clicked upon or not. And you're going to react to these events. So let's start with the form's layout. When a control is added to a form's controls collection, the control appears on the form. The control's top and left properties determine where the control appears in relation to the top left-hand corner of the form itself. The width and the height properties control the width and the height of the form. Here's what it looks like. Here's how form layouts work. The upper left of the form's container area is 0, 0. So this button is positioned with a left property of 184 and a top property of 51. Both of these measurements are in relation to the 0, 0 coordinate of the form's container area. Now there are some common properties that you'll find on most controls. Top, for example, is the number of pixels from the container's or the form's top edge. Left is the number of pixels from the container's left edge. Height and width are obviously the height and width in pixels. You'll usually find a property like text. On a button, that's the text that appears on the face of it. With a checkbox, that's what appears next to it. You also have name, which is the control's name. You don't always need to worry about name, but you can give a control a name if it makes it easier for you to refer to that control later. Let's take a look at several different controls and some of their most important properties, especially ones that are unique to that type of control. This is a form, the basic container control for all Windows and dialog boxes. It has a form border style property, which allows you to make the form resizable, which it is by default, or make it fixed size, as dialog boxes usually are. Its top and left properties are in relation to the Windows desktop from the upper left corner of the desktop's primary monitor, and that has the base 0, 0 coordinate. Forms have a show dialog method, which is used to make the form appear, and they have a hide method, which is used to hide the form or close the form when you no longer need it. For example, the OK or cancel button on a form would normally call the hide method. The class name for this is system.windows.forms.form. The text box control is circled here. It has a text property which provides access to the contents of the text box. Its class name is system.windows.forms.textbox. Checkboxes are used to indicate options, and one is circled here. It has a text property which controls the text that appears next to the checkbox, and a checked property, which is true or false depending on whether or not the checkbox is selected or not. Its class name is system.windows.forms.checkbox. Radio buttons are used to indicate a choice from a set of mutually exclusive options. Typically, you should have no more than 3 or 4 radio buttons. Any more choices than that really calls for a drop-down list box instead. All of the radio buttons on a form are considered to be a set, and only one radio button in the set can be selected at a time. Each has a checked property, which tells you if it's selected or not, and the class name is system.windows.forms.radio button. Buttons are the primary means a user has to indicate agreement or completion. Clicking a button usually closes a dialog box or takes some other action. Aside from the text property, which controls the text that appears on the button's face, and from their positioning and sizing properties, buttons don't really have many properties you'll work with frequently. Their class name is system.windows.forms.button. Finally, labels act as navigational aids and information elements on a form. In this case, they provide a caption for a text box, which doesn't have a caption of its own like buttons and checkboxes do. Their class name is system.windows.forms.label. Working with forms requires you to think about programming in kind of a different way. You see, normal PowerShell scripts are procedural, meaning they start at line 1 and they run, line by line, to the end of the script. Forms, however, are event-driven. Once the form displays, your code doesn't run until the user does something which triggers your code. Your code is triggered by something called events. For example, when the user clicks a button, that fires a click event, which you can attach code to, so that the code runs when the button is clicked. PowerShell scripts that use forms become a sort of hybrid of procedural programming and this event-driven programming model. Your script is procedural until a form is displayed. Then your script stops running until the user causes an event to be fired that you've attached code to. Once your code hides the form, your script becomes procedural again, picking up where it left off and running through to the end. Some of the common events that you're going to work with include click. Nearly everything has a click event. Buttons, but also just about any control really. Even a form has a click event. You've also got mouse move, and that occurs when the mouse is moving. Got focus occurs when the cursor enters the control. So like if the cursor enters a text box, then the text box's got focus event will fire. Lost focus happens when the cursor leaves the control. Changed. This is especially good for text boxes, and it tells you when the text inside the text box has changed. You've also got events like check changed, which is when the checked status of a radio button or a checkbox has changed. So generally in Windows PowerShell, here's how you make a form. You create the form, then you create the controls. Optionally, for those controls that have events you want to respond to, like a buttons click event, you attach a script to that control's events. You then add the controls to the form's controls collection, call the form's show dialog method, and the user interacts with the form. They type in things, they check checkboxes, they click buttons, whatever else. Eventually, some event is fired, like clicking on an OK or a cancel button, which calls the form's hide method. And you would do that from within your script that you write. So when the hide method is called, the form closes, your PowerShell script resumes and has access to the form's current controls. So you can determine what text is inside the control, what condition checkboxes and radio buttons were in, and that's when you examine all those things and you do something with those values. You can attach PowerShell script blocks to events, making them into what's called an event handler. Your script code must not launch other processes unless you don't mind those processes going off and essentially running on their own with no connection back to your script. You see, PowerShell is single-threaded, meaning it can only do one thing at a time. Showing a form is that one thing. At some point, the user has to be able to do something, such as clicking an OK button, that fires an event in which your code closes the form using its hide method. That's the only way for the form to close and for your script to resume execution. When your script calls a form's show dialog method, the shell stops executing until the form is closed. You may discover that forms offer a show method, which promises to show a form and allow your script to continue running in the background. But unfortunately, PowerShell's single-threaded execution model simply doesn't support this form feature. For the same reason, PowerShell doesn't support the use of timers or any other Windows Forms element which requires multiple threads of execution. There are some other controls you can work with. They're a little more complicated, and we're not going to cover them here, but you can use them, so you can research them on your own. This includes things like list boxes, drop-down list boxes, which are also called combo boxes, list view and tree views, and so forth. Now, there are some caveats here. Windows PowerShell doesn't have a built-in graphical form designer, and you might think, well, that's okay. I can get a free copy of Visual Studio, like VB Express, and that has a graphical forms designer. And that's true, but it won't do PowerShell. So there's really this kind of disconnect. So positioning controls on forms is usually a matter of trial and error. You put it where you think it goes, and you run it, and then you find out it's not exactly where you wanted it, so you go modify your script a little, and you run it again, and again, and again, and again, and again. And eventually you get it right, and it's really not too hard, just takes a little bit of time. So let's take a look at what a Windows Forms application from within PowerShell can really look like. Here's a fairly lengthy script that you'll find on your disk if you want to follow along. Now, I'm not going to walk through this line by line right now, because I want to start by showing you the final result. We'll come back to each section, though, and explore what each one does in some detail. If I run this, you can see that I'm prompted for a computer name. I'll type localhost and click OK. PowerShell closes the form and retrieves the operating system information from the specified computer. And this is how I prefer to use forms in PowerShell, as dialog boxes to collect information. Back in the script, you can see that using forms requires a good bit of work. Everything except the last line of the script goes into creating and displaying that dialog. The last line takes information that was typed into the dialog and retrieves the operating system information by using WMI. So now let's walk through how this was done, one step at a time. To start, we need to load the portion of the .NET framework that contains the WinForms classes. They live in a DLL named system.windows.forms. Loading it will return a success indication, which you might not want to see as part of your script's output. I usually pipe the output of the command to out null if I want to suppress it. Next, you create a new blank form. Use the new object commandlet to do this and assign the resulting object to a variable so that you can continue to work with it. This is also a good time to set the form's border style, position, and size. You can review the documentation. Just use your favorite search engine to search for system.windows.forms.form if you want to find other properties that might be useful to you. Now, this first example is pretty straightforward. I start by loading the systems.windows.forms class. Notice that I'm not piping the output to out null, so you'll see a success indication in my script as a result. Next, I used new object to create the new form. Then I set the form's text property, which appears in its title bar, and its height and width properties. Since I'm not setting a top and left property, Windows will automatically determine the position of the window. Next, I set the form border style to 3, which is a non-resizable dialog box style border. Finally, I show the form, so you can see what it looks like at this point. Running this, you can see the form appear. If I close the form using its close button, you can see that my script output did include the output of the load with partial name method. With the form created, you're ready to begin creating controls. Create each control using the new object commandlet and assign the new control to a variable. Set the control's properties, including its size and position. When you're finished, add the control to the form. You'll need the variable that contains your form, and you'll use the add method of the form's controls collection. Just pass in the variable containing the control as an input argument, and the control will be added to the form. I like to immediately call show dialog to see what my control looks like so that I can adjust it a bit if necessary. I'm extending my demo just a bit here. I'll continue to load the Windows Forms assembly into the shell, create my new form, add its text, set its height and width, and set its form border style. Rather than immediately showing it, I'm going to create a new button, set the text that appears on the face of the button, set its height, width, top and left properties, and then finally add it to the form. Next, I'll create a new text box. I'll set its left and top properties, its height and width properties, and then add it to the form. Finally, I'll show the form to see what it looks like. Getting the exact height, width, top, and left can really be a matter of trial and error. So if I'm not perfectly happy with this, I can close the form, modify my script, and run it again to see my changes. The last step is to create script blocks that will be attached to events on the form. I assign the script block to a variable, and note that the actual script code is simply contained in curly braces. One of your event handlers, such as that for an OK or cancel button, should call the form's close or hide method. Do that by simply using the PowerShell variable that contains your form. You then add the script block to whatever control events that you want, such as the button's click event. I usually do this before adding the control to the form, just to keep everything organized in my script. So I'm just going to highlight the new portions of my script now. Here's where I create the script block that I plan to attach to my OK button's click event. Notice that I'm setting the form's dialog result property to a value. Because it's possible for multiple buttons, such as OK and Cancel, to close a form, I need to have a way of knowing which button was clicked. The dialog result property lets me do that by having each button set the property to a different value before closing the form. When you call the showDialog method, it will return whatever value was placed into the dialog result property, so you can tell which was which. Here's where I add the script block to the button's click event. I use the button's variable, followed by a period, the keyword add, an underscore, and the name of the event. I'll go ahead and run this and type something into the dialog box. After I do, I'll click OK. You can see that the form closes. My script output includes the value from the dialog result property, which was 1, because I didn't store that anywhere. I just let it be output to the console. You can also see what I typed, because I had my script output that value. Here are some hints for working with WinForms within PowerShell. First of all, many different buttons can call a form's hide method. Right? If you're making a dialog box, you might have an OK button and you might have a cancel button, and you want both of them to hide the form, but they both mean something different. OK means that your script is supposed to do something now, and cancel means your script is not supposed to do something now. So before these events call the hide method, they can set the form's dialog result property to a desired setting. This setting is then passed to your script as the result of the showDialog method. So your script can call showDialog, and it can then tell whether the OK button or the cancel button closed the form, so your script will then know what to do from there. Also, remember, you're going to show a form just to collect input or display output. Try and keep the majority of the code in your PowerShell script, not in events within the form itself. Don't try to make a form that's got all kinds of built-in functionality that's triggered by events, because it gets really complicated. WinForms was designed for a multi-threaded environment. PowerShell is a single-threaded environment, at least with respect to your scripts. So there's a few things you can do in WinForms if you're writing a real application that'll just mess you up in PowerShell. So if you try to just use your forms to display output or display dialog boxes to collect information, and then close, and then let your main PowerShell script actually use that input, you'll keep yourself out of trouble. Here's my completed application. I started by creating a form, and then I create script blocks for an OK and Cancel button. Notice that each does the same thing, setting the dialog result property and hiding the form. The only difference is the value put into the dialog result property, and that's how I'll tell the difference. Next, I create the OK button, and then the Cancel button. For each, I'm adding the appropriate script block to the click event right before adding the button to the form itself. I also create and add a label to the form, and then create and add a text box. Notice that the variable name for my text box is $text1. Then I show the form. Remember that the showDialog method not only shows the form, but also returns the dialog result property when the form is finally hidden. So this allows me to see if the user closed the form by clicking OK or by clicking Cancel. My Cancel button set dialog result to 0, so if the user clicked that, my script would exit here. If they didn't click Cancel, then they must have clicked OK. So I'll use WMI to retrieve the Win32 operating system class from whatever computer name was typed. Here's where I access the text property of the form's text box, which was in the variable text1. Now I'm going to create another form. This one only has an OK button, so I create a script block for it and then create the button using the same technique as before. I create a text box, but this time I fill in several additional properties to make it a multiple line text box that has scroll bars. I turn on word wrap inside of the text box too. I populate the text box with some of the information I queried from WMI, and then add the text box to the form and show this new form. When I run this script, I'll type in localhost for the computer name and click OK. Right away, the second form pops up, displaying the information I queried. This is a great example of using WinForms to collect and display information from within a PowerShell script. Pause this video and take some time to complete this lab. Use the lab guide included on this disk to guide you through the lab tasks. When you're finished, resume this video and I'll present a sample solution. You'll also find hints and solutions right in your lab guide. Okay, let's see what I came up with for this lab. I started by loading the Windows Forms assembly into the shell. Then I created a new form. I gave it a title, set its width and height, and gave it a dialog box border style so that the form can't be resized by the user. Then I created script blocks for my two buttons click events. Each one simply sets the form's dialog result property to a different value and then hides the form. I'll use the dialog result property to determine which button the user clicked. Remember, that property is returned as a result of the form's showDialog method. You'll see me check it later in the script. Next up, I create the OK button and the Cancel button. Both get text for the button face, and they get a height, width, top, and left to give them a size and position on the form. Here's where I add my OK button's script block to the button's click event, and here's where the Cancel button gets its script block. Finally, I add the OK button to the form and add the Cancel button to the form. Next, I create a label and a text box. Again, I set their properties first and then add them to the form. Now I show the form by using its showDialog method. I check the result of that method. If it's 0, then I know the Cancel button was clicked because the Cancel button's script block set the dialog result property to 0. If that happens, I use break to simply exit the script. If the user clicked OK, I'll continue by getting the computer name from the text property of my text box and then execute a WMI query that retrieves the running services from that computer. Next, I create a second dialog box form. I also create two script blocks, one for the close button and one for a stop button. Notice that the stop button's code is more complicated. We'll come back to that in a moment. After creating the script blocks, I create the actual buttons, assigning the script blocks to their click events and then adding the buttons to the form. Then I create a label and a list box. I add the label to the form, but after sizing and positioning the list box, I need to populate it with list items. I do so here, by running through the list of services I retrieved using WMI. For each service, I use the list box's items collection, which has an add method, to add the service name. This returns a success result, which I pipe to out null so that it doesn't mess up my script's output. Finally, I add the list box to the form and show the form using its showDialog method. Back up to what my stop button is doing. When this is clicked, I first check to see if the list box's selected index item is greater than -1. It'll be -1 if no item in the list is currently selected. If that's the case, I have nothing to do. But if it's 0 or later, then a list item is selected. The selected item property gets me the selected list item's text, and I create a filter to only get the service having that name. I then use WMI to retrieve just that service and execute its stop service method. This demonstrates my preferred way of working with a GUI in PowerShell. As much functionality as possible stays in my PowerShell script. I just use the GUI to collect information. When I do need to have functionality exist in a GUI event, such as my stop button, I try to keep it very simplistic so that my event handlers don't need to become more complex and more difficult to debug.